All right, welcome back, guys. So in this video, what we're going to do is we're going to be visualizing multiple images at once. Now, why might that be useful? So suppose, you're a data scientist and you want to inspect your data set. You don't want to look at one picture at a time. You want to be able to see many images at once. And what I found to be helpful for me is to look at, about 20 images at once. So that's what we're going to do. If you want more than 20 images at once, I'm going to show you guys how you can, play with that parameter. So that's what we're going to do. Basically, what we're going to be doing is having one image, and onto the image, we're going to be plotting subplots. And so we're going to have, one bigger image like this, and we're going to have a few rows and a few columns, and we're going to be plotting subplots onto the figure. Now, before we start, I do want to come over here and click on this icon over here and make sure you only have one running instance here, one running app here, and one kernel session here. So this is fine. Here I have my MLT3 2 extra large, my MLT3 2 extra large, and my MLT3 2 extra large. The problem comes, for example, when you start your notebook and then you want to change an instance, then you have to shut them down because it doesn't shut it down for you. It creates a new instance for it. So, if you have two running apps here, two kernel sessions, and two running instances, you want to turn off the one that you're not using. So this is fine over here. What you want to make sure is you have one in the kernel session, one running app, and one running instance. Awesome. So now time to get back to some coding. So I'm going to import numpy as np. I'm going to import matplotlib.py plot as plt. By the way, I hope you guys know what numpy is. I'm actually not even sure if we're going to use it in this part. Yeah, actually, we're not even going to use it in this video. So don't worry, I'm going to talk about NumPy further on if you don't know what that is. Okay, so now I'm going to say that our figure is going to be equal to plt.figure, and it's going to take an argument called fig size, which we're going to define to be 10 by 10. And as far as I know, this will create a 10-inch by 10-inch box for us. But don't quote me on that one. I'm pretty sure it's inches, but it could have changed to some kind of other pixel value or rems. I don't know. So basically, this is going to define how big your original canvas is going to be, and on that canvas you're going to be drawing these subplots. So if we made this to be 20 by 20, it's going to be not this big, for example, but twice the size. So, but don't worry, we're going to be able to play with that. Now, I'm going to say the columns is going to be equal to 4, and the rows is going to be equal to 5. Now, so that means we're going to split up our canvas into 4 columns and 5 rows, which means we're going to have 20 spots in it, basically, for our subplots. So this way, 4 times 5 is 20. We're going to be able to visualize 20 images at once. So if you want to visualize more than 20 images, you just change these numbers over here. Awesome. Now let's define our function. So I'm going to say visualize many, and it's going to take in a few inputs: the from number, the to number, and the data set. Now, the from number and the to number might be tricky at first. So let's suppose my from number is 100 and my to number is 120. Now this means that I want to be able to see the 100th image and everything in between 120. So that way it's going to display to me the 20 images with the indexes of 100, 100, 100 to and on until 120. Now if I wanted to visualize maybe the first 20 images, I could do from 0 to 19. Total we have 517 images, so we could even do something like from 497 to 517, and that way we're going to see the last 20 images. So basically you get to visualize somewhat random images because you don't know what you're getting, but you're telling it the indexes, and the data set is going to be either train or validation. And I'm actually going to copy this part over here because we're going to be using the same way to tell the function, which data set it's using, except I like to rewrite some things to avoid, confusion. So I'm going to say that the data set path is going to be equal to train images path if not the split, but the data set, which we're getting from here, and data set over here, and data set over here. So basically what we're saying with this one line Python function over here, Python conditional, if you haven't seen one yet, this is it's going to be equal to this if this is train, else it's going to be equal to this if it's equal to validation, else it's going to be 0. And the reason I put else 0 is because we can handle errors better, because if the data set is equal to 0, we can raise an exception. So basically the data set path is either going to be the train images path or the validation images path, which is what we defined over here above. So we can just copy that and paste it in over here. Awesome. Now we can come to the fun part. So I'm going to say images path is going to be equal to glob dataset path. So the images paths is basically going to be the paths of every single image. And the way we can do that is recursively go over the dataset path, which is either going to be this or this, and then just, recursively go over it with glob. Awesome. Now we have the images path. Now I'm going to set an index counter for our subplots so we know which subplot we are at for Matplotlib, and I'm going to set it to 1. And then over here, I'm going to say for I in range, and we're going to say the from number and the to number. So remember, we're going to go over the range. So if the from number is 100 and the to number is 119, that means we're going to, loop over those images with those indexes. Awesome. So now we also need an internal counter so we know which image basically we are at. So this I is going to be equal to the counter basically. So we could use I, but I just like to specify a counter. So I'm going to say image is going to be equal to images paths, and we could say I, but I just like to say counter. That's the same thing. And then I'm going to say that the image is going to be equal to mp image dot imRead the image, and then I'm going to say figure dot add underscore subplot. So this is where we're adding a subplot to our image. Basically, we're going to add 20 subplots total. And here we need to give it the rows, columns, and the index counter. Now it knows the rows and the columns because we defined it over here, and it keeps track of the of what part of the area has been used by the index counter, because basically we're telling it that the index counter is 1, and at the end we're actually going to do an index counter plus equals 1. So for the next time it's going to add a subplot, the index counter is going to be the second element, so it knows to add the subplot as the second element. But before we do that, we also have to do a plt.imshow image over here. And once we're done with the for loop, we're going to do plt.show. Now let's try and make sure we didn't do any errors. So I ran it with Shift Enter to see if we have any syntactical errors. None so far. So I'm going to say visualize many. I'm going to call the function, and let's try and look at the first 20 images. So I'm going to say from 0 to 19, and the data set should be train. Now we might have some issues the first time we run it, so don't be alarmed. Yep, name glob is not defined. Okay, so we actually have to import glob and then rerun it. Remember, rerun the cell if you changed anything, and then we got to rerun this. MP image is also not defined. Oh, right, because we See, this is good that we have these errors come up because now, even though we imported it over here, I didn't run this cell because, I restarted my kernel. So you're going to have to rerun it or just copy it. And I copied it. I'm just going to paste it here, rerun this cell, and then name columns is not defined. Oh, right, because I misspelled it. See, this is live debugging for you guys here. Okay, let's see if we get this right. Awesome, so 4, 8, 12, 16, 19. Actually, yeah, for the first 20. Okay, okay, yeah, so I think what we're gonna have to do is maybe run this in the same cell. Let's try that, shall we? Yeah, so this is an error with Matplotlib, is that you're gonna have to run it, call the same function when you're visualizing it within the same cell. Otherwise, you have to specify some other things, and I think that would overcomplicate some things. So I think it's easier. Semantically, it might look nicer if, you call the function from a different cell. So if I move this out here and called it from this cell, but as you saw, new instances. So, and I know how to fix this, adding access using the same arguments, but I think it's too big of a hassle and it would overcomplicate things for you guys. So just make sure you run it from the same cell. And it's running, and as you can see, we have visualized the first 20 images. We have a plastic bag, plastic bag, plastic bag. I'm just gonna cut this. And now let's, give it a try. Let's try and look from, 100 to 120. And as you can see, it's still working because of the asterisks. And awesome. We have the images with these indexes from 100 to 120. Awesome. Now we could do, maybe from 320 to 340. I like to, double check to make sure my function is working properly. And I also like to deliberately break my function. So how could we break this? Well, let's say I want to run it from 500 to 520. And remember, we only have 517 images in the train folder. So let's try and break it. As you can see, list index out of range. Awesome. That means we were able to break it. Now, what if we use the validation? And I'm going to say from 0 to 9. Because remember, we only have 9 images in the validation one. So what's going to happen if I run this? As you can see, it's still running. And we have 4, 8. Okay. Okay, yeah. So as you can see, this was the output of the previous run. That's why I was confused. I was like, we have a lot more images, and here are the 9 images from the validation. And you can make this disappear by, rerunning it. Sometimes SageMaker caches certain things, and as you saw, it cached the previous function. So no worries, you just have to rerun the cell. And as you can see, in the validation, it displays all the 9 images in our validation data set. And even though we said that it should have, 4 columns and 5 rows, it has 4 columns, but it's smart enough. Matplotlib is smart enough to know that, it does need 4 columns, but we don't need all 5 rows because all of our data can fit onto 3 rows. So I hope that made sense for you guys. And if you have any questions, let me know. And I know that, it can be tricky with Matplotlib when it caches things, but just remember, if there's some weird behavior, then just rerun the cell and I guarantee you it's going to disappear. So I hope you guys enjoyed this, and also don't worry too much if, you don't completely understand how this figure.add subplots work and everything, because this has nothing to do with machine learning or building machine learning pipelines on AWS. This is only a way for you to better understand your data. So that's why I didn't want to go into too much detail and fix all those weird bugs that you saw. For example, if we run this function from another cell, because I like to keep my course focused on what's important, which is machine learning pipelines on AWS. And obviously, visualizing images is a part of it, but it shouldn't be more important. And so I don't want to spend extra time on it. So thank you for your attention, and I will see you in the next video.